Okay, so we want to look at the value R, which is the universal gas constant. All right, so we know that for an ideal gas, PV is equals nRT. And this is the equation of an ideal gas. From this equation, we can say that R is equals PV over NT. And of course, we remember that for this R, P here is pressure, and then V there is volume, and then of course we have number of moles of gas, and then we have temperature in Kelvin. Now of course at STP, under standard temperature and pressure, we know that at STP we have that pressure is equals 1 atm, then the volume occupied by 1 mole of gas under standard temperature and pressure, of course, is a constant, 22.4 dm cube, or 22.4 liters, okay, or liters, or liters. Then, of course, number of moles is 1 mole. So 1 mole of gas will occupy 22.4 dm cube at pressure of 1 atm, and then at a standard temperature of 273 Kelvin. So if we put this into the equation, we're going to have that R is equals 1 atm times volume, that's 22.4 dm cube, then divided by 1 mole, then times temperature of 273 Kelvin. And then, of course, if we do a multiplication and division, we have that R will be equal to 0.082, then 0.5, okay, which we can say 1. Then ATM, be careful of the unit. The unit is our interest here. Then mole per K, per mole per K, which we can also write as 0.0821, then ATM dm cube, then per mole this way, then per K, okay? Now, of course, these are not standard units. These are not standard units. However, we can write this in standard units. So in standard units, if you remember, we remember that 1 atm is equal to 1.01325 bar. Okay, this in bar. And then, of course, this is also equal to 101325 Pascal. 101325 Pascal. And if you remember, the Pascal is, if you do pressure, force over area, that is a force in Newton, and then area in meter squared, you have that that is equal to 1 Pascal. So Newton per meter squared. Pascal is equal to Newton per meter squared in base unit. Then, of course, again, if you can remember, okay, maybe we should derive it so that I don't give you a straight value. If you remember, 100 cm is equal to 1 meter. That's true. 100 cm is equal to 1 meter. So if we cube both sides, okay, cube both sides, then we're going to have that 100 cm, okay, cubed is equal to 1 meter, and then cubed. Then 100 cm cubed is 100 cm is 10 raised to power 2 cm. So, and this is what we're cubing, is equal to 1 meter, and then we cube this. So if you cube this, then we are going to have 10 raised to power 6 cm cube now is equal to 1 meter cube. Okay, 1 raised to power 3 is 1, and then meter raised to power 3, that is meter cube. The same thing here, 10 raised to power 2 cube, the powers multiply, indices, and then cm cube, and then we have this equal to 1 meter cube. So this now, if we can still remember, 10 raised to power 3 times 10 raised to power 3 is also 10 raised to power 6, and then this in cm cube, okay, is equal to 1 meter cube. And that is to say that we can say from here that 10 cm cube, okay, 10 cm cube, or rather 10 cm cube, that's 1000. This is 1000. 10 raised power 3 is 1000. So that is to say 1000 cm cube, okay, 1000 cm cube. And then this comes down here to divide. That means 1 over 10 raised power 3 meter cube, okay. And then that is to say that 1000, okay, cm cube is equal to 10 raised power minus 3 meter cube. That is to say 1000 cm cube is also the same thing as 1 liter. Okay, so 1 liter or 1 dm cube. So 1 liter or 1 dm cube is equal to 10 raised power minus 3 meter cube. In other words, 1 liter or 1 dm cube, 1 dm cube is equal to 1000 meter cube, 1000 meter cube. So let us now put these two and then convert the value of R to standard units. So if we want to do that, then we're going to say that since we know from here, we had a value of 0.08205 accurately, 205, then ATM dm cube per mole per K, per mole per K. So if we are to convert this ATM, our purpose is to convert the ATM here, okay, into Newton per meter squared. And then that is to say we're going to have, this is 0.08205, then ATM, each ATM is equal to 101325 Pascal. So that means 101325 multiplying this, then this is Newton per meter squared. Okay, we have converted this ATM into Pascal by this multiplication. Then dm cube is 1 dm cube is equal to 10 raised power minus 3 meter cube. So that means if we multiply this now by 10 raised power 3 meter cube, okay, we have also converted this. So there are 1 dm cube per, so this is per dm cube. So there are 10 raised power minus 3 meter cube per dm cube. So we have converted this cancels out this. So we have, then this is per mole, then per K. So if we do this multiplication, we're going to have 8313.7, okay, then Newton per meter squared, then multiply by 10 raised power minus 3 meter cube, then of course per mole per K. And then of course let us now do the remaining things. This times this value times 10 raised power minus 3 will simply mean 123, and that means 8.3137. okay, then meter squared, let's now do the units. Meter squared cancel meter cube, okay, so we have a meter there, so that means Newton meter, then per mole per K. And so if we take up these values now, then we're going to have that this shall be 8.31 and then maybe 4, then Newton meter, then per mole per K. If you remember, force times distance, okay, is equal to work. And what is the unit of work? Joules. So 8.314 joules per mole per K. Now also, of course, this can be given in other values. We can write the universal constant in other values. This is one of the values of the universal constant. We can write the universal constant in other values, okay? Any unit of work at all, in any unit of work, okay? R can be written in any unit of work, okay? How do I know that? Now, I know that by showing you again that R is equal to pressure times volume, okay, divided by number of moles. So moles times temperature or degree, however you call it. Then, of course, you remember that pressure is equal to force over area. Pressure is force over area multiplied by volume. Now, volume can be area times length, if you remember, okay? So instead of doing length times width times breadth, so the other two will give you area. So area times length, then divided by mole times temperature, okay? Then area can take area, and then that means R will be equal to force then times length. So force times length divided by mole times temperature, okay, or degree. So force times length here is equal to work. So work then per mole then times degree. Okay, so that is to say any unit of work at all, we can use any unit of work to express R. For example, calorie. Okay, of course, you know that 1 calorie is equal to 4.184 joules. So if that is so, that means I can have my R. Okay, since my R is 8.314 joules per mole per K, then I can have that this is equal to 8.314. To convert these joules into calories, I divide this by 4.184. Okay, so this is joules per calorie. So there are 4.184 joules per calorie. So when I do the division, then this will be converted. The joules here cancels the joule here, and then the calorie comes up. So this will be in calorie, then per mole, then per K. So this will give me about 1.987 calories then per mole per K. Other values are known. Other ones, such as we have mentioned calorie. We can use X also. If you remember, 1 joule is equal to 10 raised power 7 X. Okay, so if you do that, you also see that R will be 8.314 then times 10 raised power 7 X then per mole per K. R can be expressed in every other unit. Okay, if you express R in bar meter cube per mole per K, and then try to do the conversion we have done by using this. If you remember this relationship, that 1 ATM is equal to 101325 bar, and then you try to do the conversion, you're going to observe that this will give you in bar 8.314 times 10 raised power minus 5 bar meter cube per mole per K. So R can be expressed in every other unit, but most times what we experience in our calculations are R expressed maybe in calories, or R expressed most times in joules per mole per K, or R expressed most times in ATM dm cube per mole per K. So these are values of the standard unit R, and then depending on the question you want to solve, it is important to know what the units R is in, so that you can effectively do conversions where necessary, and then have units cancel out appropriately. Thank you.